Welcome to The Explainer. You ever wonder what the real math is behind a lucky guess? Well, today we are going to demystify probability. We'll kick things off with a simple coin toss, and then build our way up to the big rules of chance. You know, the ones that shaped everything from the games you play to some pretty major life decisions.
All right, let's start with a total classic, a question everybody thinks they know the answer to. You flip a coin. What are the chances it lands on heads?
Yep, exactly. One chance out of two. It's a 50-50 shot. Simple as that.
Seems pretty straightforward, doesn't it? But believe it or not, this super simple idea, it's the launchpad for understanding way more complex odds. Okay, so let's make things a little more interesting. What happens when we start combining events? Like, what's the probability that you get heads and you roll a 6 on a die? Ah, see? Now that's when things start to get really interesting. This is where the real power and, honestly, the fun of probability really kicks in. So, first things first, we gotta understand what a simple event is. Think of it as the absolute foundation, the most basic building block of all probability. A simple event is just a single thing happening, just one isolated action. So tossing a coin once, that's a simple event. Rolling a die one time, also a simple event. The key thing to remember is one action, one outcome. Okay, so what happens when we start chaining these simple actions together? Well, that brings us to our next big idea, the compound event. So, check this out. On one side, you've got your simple event, just tossing a single coin. But on the other, you've got a compound event. You're spinning a bottle and you're rolling a die. See the difference? It's all about combining multiple simple events. So a compound event is basically any outcome that's made up of two or more of those simple events. And this is how we start to figure out the odds for more realistic, more interesting stuff that happens out in the real world. Okay, but here's where there's a really important twist. What happens when the result of one event actually changes the odds for the next one? This is a super crucial distinction.
First up, let's talk about independent events. This is exactly what it sounds like. Two or more events where the outcome of one has zero effect on the outcome of the others. Let me give you a quick example.
Okay, imagine there's a cooler with, say, 10 sports drinks in it. You reach in, you grab one, you see it's lemon lime. Great. Now here's the crucial part. You put it back in the cooler. So when your friend goes to grab a drink, the odds for them are exactly the same as they were for you. Your choice didn't change a thing. The two events are totally independent.
But what if you didn't put it back? What if you, drink it? Well, that leads us straight into dependent events. And this is where the outcome of one event does affect the outcome of the next. Think about a box of chocolates. You pick one out, let's say it's milk chocolate, and you eat it. It's gone, right? So now, when the next person goes to pick one, there's one less chocolate in the box. The total number of options has changed. That second choice is now completely dependent on what happened in the first one. All right, so far we've been talking a lot about this and that happening together. But what about when it's a question of this or that? This introduces us to a whole different category of events. We call these mutually exclusive events. And the name really says it all, It means they can't possibly happen at the same time. If one happens, the other one is automatically excluded. A perfect example, rolling a single die. You can roll a 2, or you can roll a 5, but there is just no way you can roll both a 2 and a 5 with one single toss of the die. It's impossible, so those outcomes are mutually exclusive.
Okay, so we've got all these concepts swimming around, right? Simple, compound, independent, dependent, mutually exclusive. So how do we actually calculate the odds? Well, let's open up the toolkit and take a look.
So, one of the easiest ways to figure out the probability of a compound event is to just map out every single possibility. If we go back to our coin and die problem, this table shows you everything that could happen. There are 12 possible outcomes, from getting a head and a 1 all the way to a tail and a 6. And this whole set of all possible outcomes, we call that the sample space. Another really cool tool is a tree diagram. It's perfect for when something happens multiple times, like flipping a coin 3 times in a row. You can literally just trace the branches to see every possible sequence of events. And as you can see here, this diagram shows us there are exactly 8 different outcomes from those 3 flips. Now, behind these handy visuals, there are some pretty simple rules of the game. If you want to know the odds of event A and event B happening, you multiply their probabilities. Super simple.
For dependent events, you still multiply, you just have to adjust the numbers for that second event. But, and this is a big but, if you're looking for the odds of event A or event B happening and they're mutually exclusive, you add their probabilities instead. So remember, and means multiply, or means add.
So, why does any of this matter? I mean, beyond just games or a math quiz, right? Well, it matters a lot.
Because understanding these principles is absolutely fundamental. This isn't just about rolling dice. It's the same logic that powers weather forecasts, stock market predictions, even those algorithms that tell you what movie to watch next. The rules of chance are literally everywhere, playing out all around us. So the next time you're facing a decision with an uncertain outcome, maybe just stop and ask yourself, what are the odds?